So here we are using strain gauge to find out the load versus strain of the cantilever beam. What is the output of load versus strain? So here we are using strain gauge for this purpose. Strain gauge is a piezo resistive transducer. These are different types of strain gauges here. These are piezo resistive strain gauges. When we are applying load, resistance will change. That is why it is called piezo resistive. So we are using different types of strain gauges. Here we are using foil type strain gauge. This foil means foil strain gauge. This is foil strain gauge. This is wire strain gauge. This is also wire strain gauge. This is another type, foil strain gauge. Two strain gauges in 90-degree angles. This is also foil strain gauge in half bridge. This is also in half bridge. This is used for torsional load measurement. And the specification of the strain gauge is to see the resistance. Resistance we have to specify. Or it is 120 ohm. 120 ohm is the resistance of this strain gauge. This is 350 ohm. And gauge factor. Gauge factor is 1.9. Gauge factor decides the sensitivity of the strain gauge. That is change of resistance per unit strain. If this value is more, the sensitivity also high. So here it is 1.9. So the sensing circuit for this strain variation is Wheatstone bridge circuit like this. There are 4 resistances and 2 points for applying excitation voltage, P plus P minus, points for applying excitation voltage, and the output resistance variation, output in terms of current, that is between the S plus and S minus, these 2 terminals. So here the excitation voltage is 1.5 volt, that is permanent voltage we have to apply, DC voltage we have to apply to get the output. So this is a full bridge configuration. Then half bridge configuration. For half bridge configuration, there are 2 strain gauges. One strain gauge is of this 2 strain gauges. One is in tension mode and other is in compression mode. So in this one, when we have tension increases, resistance will increase. This is in compression, so resistance will decrease. Tension, compression, that is in half bridge mode. This is quarter bridge. When we are using single strain gauge, that is in quarter bridge. So other 3 resistances comes internally in the circuit, and other 3 standard circuit included internally in the circuit, and that is why completing 4 bridge circuit. Now we can see the connections. Here the P plus P minus, excitation voltage, S plus S minus, signal output for. So all this is for full bridge configuration. So here we can see this for wires are for full bridge configuration. We can connect to P plus, here, then P minus here, S plus, S minus, S minus. So this is the connection P plus P minus, S plus S minus. Now we have to set the gauge factor. Gauge factor here, this knob is for setting gauge factor. Gauge factor is 1 by gauge factor is the value we have to set. This is 0.4. 2 is the gauge factor, so 1 by gauge factor is 0.5. So this you can adjust this knob to get 0.5. Now this is 0.5. This measurement mode. This is measurement mode. Then type of bridge you have to select. That is full bridge, This is full bridge configuration, this is half bridge configuration, this is quarter bridge configuration. So now this is in full bridge. Now you have to select the resistance. This is the knob for resistance, 120 ohm resistance, 350 ohm, 600 ohm. Our strain gauge is 120 ohm. So now this is 120 ohm. So the setting is okay. Here this knob is for initial 0 setting, but some problem for this knob. So you have to note the initial reading, then next final reading, like that. So rounded strain gauges here, 2 strain gauge here and 2 strain gauge at the bottom for full bridge configuration, and for half bridge 1 strain gauge here, 1 strain gauge here, that is the center one 1 strain gauge at the center and other strain gauge at the center bottom for half bridge configuration, 2 strain gauges at the top and 2 strain gauge at the bottom for full bridge configuration. And from the half bridge we can select 1 strain gauge for quarter bridge operation also, either at the top side or at the bottom side. Now this is connected in full bridge configuration. So you can see the strain gauge mounted here. After cleaning the metal surface, we can, by using epoxy adhesives, we can fix the strain gauge on the top surface. Then after fixing using resins, we can solder the wire to get the electrical connection. So now this is already connected. Now this configuration is full bridge. So we can check the reading. It's a weight hanger, and we can load the point here. This is the loading point, and strain gauge position is here, and the cantilever starting position here, this line. Here it is mounted. So total length of the cantilever is this line from to this point of suspension. So we hang the hanger here. So initial reading is 229. Then apply the weight. So this is hanger weight is 400 gram. This 250 gram step. So 1 kg, and this is 1.5 kg, total 1.5 kg now we applied. So 312. Previously it is 230. Now 512. So the value is 28282. Okay, this is for the full bridge configuration. Now we can increase the consecutive reading by applying 250 gram and not the reading. Again 250 gram, not the reading, like that. So from this load versus, you can draw the graph of load versus strain. Now we can check the reading for half bridge configuration. Disconnect this one. For half bridge, one wire is this P plus, other blue wire is P minus, one of these white wire is S minus. Half bridge like this, one strain gauge at the top, other strain gauge at the bottom, and this wire to P plus and this wire to P minus. From this is the joining point, this is to S minus. P plus S minus. This is the connection. Now change the full to quarter or half. Half. So, bridge resistance 120 ohm. This initial reading is 1461. Now you apply the load. One 1506. So the difference is 5, 4. Okay. 45. Now we can check the quarter bridge connection for the same load. Or quarter bridge, this is the connection. There is no this one. P minus 1 strain gauge is not required. So you remove the P minus. Now it is quarter bridge. So from the junction same wire 120. Remove the this one P minus. This is quarter bridge. That is P plus S minus quarter bridge. Resistance 120. Okay. Initial reading 2144. 2144. 54. Problem. Then load the 2189. 2189. So the difference is 5, 2. So 25. Actually you have to get for full half. This is half bridge. Now the reading is 25. So the double of this reading, 40, some slightly error, and this one 90 only. This one, this is having some error. Actually it should come 90. Previous reading is 312, not 512. By instance, here one display segment, one line is not a display. That is why you are confusing. So here this is 312. The second reading is 230. Now the difference is 82. So actually also quarter for quarter bridge 25, you are getting nearly double 45, then double, we are expecting the double. Now what we are getting 82 here. So that is the relation between these three types of bridge. So depending upon our application, we can, if you wanted only one axis load, we can go for this one quarter bridge, and two axis we can use the half bridge, one at the top, one at the bottom, tension and compression will get. Or if you want to lattice strain also, three axis, we can go for full bridge configuration. So all the three force component we will get by using 4 strain gauges in full bridge configuration. So this is the experiment we are doing here. For full, we are repeating the experiment in full bridge configuration by placing the weight step by step. Not the reading in step by step and find the load versus strain graph and find the cross section area of the beam and length of the cantilever. From that you can calculate the Young's modulus of the moment of inertia, then Young's modulus you can calculate. Okay.